So for 7.2, show that the length of CD is equals to 3p into sin x plus cos x over root 2 sin x. So CD, if we have a look here, is the bottom in the bottom triangle, and essentially what we will basically have to do is we will need to figure out which triangle and it looks like some sort of maybe potentially sine rule here. So for us to be able to do that, we would need two pairs. So it looks like we do. Let's have a look. So basically CD all over, and this is sine, and in this specific instance it's going to be 180, because if you look at the triangle here that we have, we don't have angle CAD, we have at ADC is 45 degrees, and we know ACD is x, so it'll be 180 minus 45 minus x, which is 135 degrees minus x. So sine 135 degrees minus x is equals to, and what we do have is we have AD to be 3p, so here it will be AD, which is 3p over sine of that angle, which is sine x. So now this is what we have to work with, and it looks like we have everything in terms of p and x, so that's a good sign. So let's first get CD on its own. So it'll be CD is equals to 3p sine 135 degrees minus x all over sine x. And that's a good start. Why? Because we have a sine x at the bottom, and we also have a 3p at the top, and so we need to somehow get sine x plus cos x and that root 2 somewhere from our calculation. So in the sine x, in the sine 135 minus x, that looks like our common formula, a minus b, a minus b, and basically here CD is equal to 3p, and we can expand this to be sine 135 degrees cos x minus cos 135 degrees sine x all over sine x. So 130 cosine 135, if we reduce that, that becomes sine 45. So it's in the second quadrant, it becomes 180 minus 45. So we just reduce that, that becomes sine 45 degrees cos x, and cos 180 minus 45, which is cos 45 degrees sine x all over sine x. So now sine 45 cos 45, those are our special angles. So CD is therefore equals to 3p root 2 over 2 cos x minus root 2 over 2, and this is in brackets. Should put this in brackets actually, since this 3p was on the outside, so put that in brackets. Cos minus root 2 over 2 sine x. So what we can now do is, and this is negative, and what we can do from there, since we want our value to be positive, we can then change our sign and actually factor out a minus sign and actually change around these two things. So here, if we change these things around, since that's what we wanted, we can then make it root 2 over 2 cos x plus root 2 over 2, and changes because of this cos 45. So this cos 45 makes it, so this is 180 minus, and cos is negative in the second quadrant, so that's how it becomes positive. So it becomes positive there. So root 2 over 2 sine x, and looks like we have our answer almost. We would just need to factor out our root 2 over 2. So to do that, let's first factor that out. So if you factor out root 2 over 2, so 3p root 2 over 2 cos x plus sine x all over sine x. And what we can do now is to rationalize this. Another value for, or another representation of root 2 over 2 is 1 over root 2. And what would that basically do is that will take this bottom root 2 at the bottom, which is what we want. We'll get 3p times the 1 into cos x plus sin x all over root 2 sin x, and that is basically what we wanted for CD in terms of x and p.